Thanks for everyone for joining our webinar today. Our focus will be focusing on simulation training construction for operators. I'm very apologetic for what's happened. Again, it's kind of out of our hands. We had to postpone our event last week due to everything else that's going with COVID-19. Obviously, our safety, our colleagues and friends and people that we're in touch with is the most important thing. So, hence we had to cancel the event like everything else. I hope everyone is keeping safe and everyone's doing well. We will be postponing this event to sometime maybe in summer or a later date when we have a better, a clear understanding when we're going to get back up to to normal speed and up and running again. So we'll keep you posted. We'll let you know when we will do this event, and hopefully we'll try to get the speakers back from CITB, from NOCN, and the guys over from John Deere from America. We're very sorry for any inconvenience caused to anyone else as well, but it's kind of, it is what it is. For today, we're going to try to keep it very short. It's just an hour just to give you guys an update of what we're going to cover in our event, essentially. We're going to speak mainly about the advantages of using simulation in construction and operator training. Our focus is going to be the tools that are coming out, the return of investment, and how it can help impact your business. Drew Carruthers from CM Labs is the director of products, and he's going to give a presentation. So I'll hand over soon to him to go through the agenda and to speak for the rest of this webinar. With that being said, I'll pass on to Drew to introduce himself and CM Labs, and we can go ahead. Thank you.
Thanks for that. Okay, I really appreciate you guys spending some time with us today. It's as Amir was saying, it's a bit strange and a bit odd, but I think we're kind of getting along with it. So what I'll do is I'll go through what I'd like to talk about. So basically, this is going to be the agenda, a little bit about who we are, talking about simulation, our approach to training, the way that we kind of, our philosophy towards when we design something, and basically ending with kind of a quick overview of our solutions and some talk about our clients afterwards. So I'll give you a little bit about who I am. I'm the Director of Product Strategy at CM Labs. I've been with them for 8 years now, mostly working in product. Started the product group, overseeing all the development of the products, designed all the hardware with them in mind, keeping these things as focused towards the construction industry as possible. So CM Labs basically is focused exclusively now inside the heavy equipment training operation, with a sidebar in working with simulation platforms. So heavily into port and construction, with some forays into defense and off-road, but really construction is our bread and butter. So to encapsulate what we like to do, we want to simulate the world's work sites and make operations safe, efficient, and more effective. We like to talk to people, and we like to find solutions to their problems using technology. So mainly it comes down to the construction and the port side, that we have installations in the UK right now on both of those pieces of equipment. The custom simulation services are the ones that are really the people who have a very purpose-built simulator. What you see there on the third pane is something that was done for Siemens there. They had a windmill erection need. So a giant custom solution for them. And everything that you'll learn coming on, everything was built on something that we call Vortex Studio Platform, which is an editor that creates something from nothing, physics-based simulation using the Vortex editor. So we are a company that's very vertically integrated. All design is in-house on the software and the hardware. We build them in-house. We do as much as we can in-house to try to get some efficiencies that way. So construction, again, is our bread and butter. Construction breaks down into cranes and earthworks. There's a picture of the tower crane there. The earthworks side is what we really try to differentiate ourselves in, is that it feels like the real equipment. The cranes feel like the real equipment. So we really, as it goes on, you'll see that that's kind of the way we're approaching things, is that we want to make sure that when you're sitting in the seat, that you're getting experience, you're having a little anxiety, you're gaining respect for the machine. On the port side, I know the focus isn't on port right now for this webinar, but port is really interesting because it's big, expensive pieces of equipment with a very simple to say purpose take the containers off the ship or put the containers on the ship. So that one is really about efficiency training. And finally, in the defense sector, highly custom equipment, highly custom machines, very mission planning type things. So we really push our boundaries on creating the equipment, but also putting that equipment into tandem operations, into working with your friends, and to deliver a specific objective of a mission. So each one of those things are built on the same platforms, but end up having different strategies when you're devoting yourself to training. So we have installations all over the world at this point. A lot in North America, spreading out or on pretty much every continent at this point. So why simulation? Before I was with CM Labs, I was working in the aircraft simulation business. And what you get with aircraft simulation business is if the pilot is going to be training on a simulator, they're mandated to, they must. They can train exclusively on the simulator, and the first time they even see the real aircraft, they can be the pilot with people on board. And that's a frightening idea until you kind of grasp at the level of fidelity that simulation must be able to achieve, that the simulator behaves exactly like the aircraft that they're going to go fly. So they've got lots of money, they've got giant consequences, so therefore it developed very quickly. Port and mining also have lots of money, less consequences, but lots of returns on investment. So they're actually relying on simulation very, very heavily. And as that technology becomes cheaper and cheaper, it trickles down into our industry, into the construction industry, where we kind of take those technologies and apply them to people who aren't going to be spending $8 million on a simulator. So port operations, mining operations, and aircraft, they all have different purposes, but they all use simulation to achieve their objectives. So why are they choosing simulation, and how can we apply that into our industry? Well, the number one thing is fuel consumption. If you can believe, and I hope to convince you, that simulators, the experience on them, feel like the real equipment, that when you're on it, that you're having something that will transfer to the real site, then you can believe that the time on there, you can develop skills. And if you're developing skills on that without using fuel, you're going to save costs right away. You'll save your maintenance, you save your wear and tear, you save your insurance costs, you'll save, there'll be no incidences happening. And at the same time, you can have multiple people on multiple pieces of equipment with only one trainer, or even an IT who is overseeing a 3-hour scenario, observing that stuff. So the risk mitigation is completely on the opposite side of equipment training. So another reason to do it is to accelerate your training. If you're given 6 weeks to do training, 4 weeks to do training, or a week to do training, how can you get somebody through there as fast as possible, elevating an entire class where you have some people who are very smart and some people who require more attention? How do you get them all to the highest possible common level as possible, as achievable within the time resources? Well, you can use simulation. There's more seats, there's more time to fail, there's quicker resets, you don't have to rope off the yard. So everyone gets more experience, and their muscles learn, and their jitters calm down, and their mind calms down. So when they're getting on the real equipment, they have a sense that they've been there before. You can tell them to go and into the lab and to try the exercise 10 times. You can't do that with real equipment. So they can take in charge, and they can spend some quiet time. If they're a little bit nervous working around other people, they can have some time to calm themselves and then realize that they're actually okay at it. So what the simulation does is it really kind of gives people a chance to learn at their own pace. This is what I like the most, and this is what I see the most. What simulators do, what our industry has, is a problem with recruitment. For some reason, kids start off playing with construction equipment. It's the coolest thing in the world, and something happens until when they become an adult that they don't consider the trades anymore, and I don't understand that. It takes good care of you, it's good pay, and you don't need a PhD to do it, and that's a good thing, because you get common sense people into the industry who are just as good as anybody else. So what the simulator allows schools to do is to recruit people who wouldn't generally consider simulation as a trade. You can get them into a room, You can say, close the door and saying, let's see how it's done. There's no loud equipment. There's no people watching. There's no people smiling and laughing. You just get to find those little jewels in the rough of operators who are smart, but just need that moment to recognize in themselves the potential that they do have. So that's what simulations can do. And you can test skills in a very, very objective way so that if you're doing the same exercise over and over again, then you can find the people who are better decision makers, the ones who don't treat the simulator as a video game, who aren't the cowboys. You can find these people, bring them into our trade, and then our trade will be better for it. So that's one of the things I really, really like with simulators is the quiet time and the ability to discover those people. And everything is recorded. So you get to see runtime. You get to see 2 months afterwards. You get to compare apples to apples. Everything is recorded. You'll have up to 60 metrics that are being recorded, everything from fuel consumption to collisions to cycle times. You can find out the people who are polite to the machine, who just need more experience on the machine to become more efficient, and you can send them down a path. And you can find the people who need to learn to respect the machine and who are having many, many collisions. And you can send them down a different path to work maybe on more precision training, on positioning the bucket or steadying the swing on a crane. So it's very, very objective, and there's no lying with the results that you can take a look as an instructor, and really sit down with them and deconstruct the experience that they just had. So just to give you a little idea of what CM Labs is as far as a company, we're a company founded on the belief of physics-based simulation. So what we're calling smart training technology. What that means is that we can take the fidelity of the simulation that exists in aircrafts and put them into the construction and support sector. So we simulate engines, and that engine is connected to a governor, or that engine is connected to a hydraulic pump, a variable displacement pump. We simulate that, and we simulate the hydraulic pump that has a rod side and a head side, and we simulate the safety valve. And what we do is we piece all those little tiny pieces together and have emergent technology come out of that. And then we tune it, and we tune it, and we work with real operators so that the equipment becomes the sum of individual parts, hopefully feeling like the real equipment. And a very quick technology of how that, a quick story about how that comes out. I've worked a lot with a company called John Deere who makes heavy equipment for earth moving. So when I started my relationship with them, I went down to talk to them and said, they were skeptical about the fidelity that I could bring to the simulators. So what I said, and we got the lawyers to sign on, is I'll do all your equipment. I've done 7 of them now, and they signed off. And I won't release it. I will keep correcting it until one of your professional operators comes up to Montreal and says it feels like the real equipment. They have, I think, 12 professional operators. Send anyone you want. I will convince them that this feels like a John Deere piece of equipment before I release it. So they agreed to that, and we've been successful at releasing 7 pieces of equipment now. But you can't do that without things that are inside the smart training technology. And where we're going with that is something called predictive training. So we're slowly moving towards collecting data and helping instructors understand the different paths that people take to becoming great operators. Whether they need to go towards efficiency training, whether they need to go towards precision training, whether they might be best worked with tower cranes or excavators. So we're now using the data that we're collecting to give that information to instructors to help them understand why is this operator different than the other operator or students, and therefore you can accelerate their learning. So what we do in every one of our simulators, we like to make them as self-learning as possible. So every time you start a exercise, you're going to do a fly around, and you'll have little tips here that we get from our clients. That these are the things as an instructor. I used to be an instructor for flight simulation. You say the same thing in the first 5 days. They almost go into autopilot. Well, we put those tips into the actual simulator so that they don't have to, or that they're reinforced. Remember, we're going to be digging now. You start at 8, you end at 5, you curl the bucket, you enter, your teeth enter at 90 degrees to the soil. Little tiny tips just that get reinforced every time you're doing an exercise. And we always record all the information, and we customize the scoring, or to say you customize the scoring. You take all the metrics that we collect, and you can use or not use any ones that you want, and have the student evaluated on your criteria, your values. So that if your values are low collisions, don't care about fuel, or if your values about low cycle time, you put that in there. And when the student starts an exercise, they start at 100% and they get deducted for the bad behavior that you just set. If you have multiple simulators, you set it once, and then all the simulators will follow the same rules. And you can set different rules for every exercise. So whatever you want to do. So we really push that out to you guys to set your values inside the simulator. And whenever you do that, inside the report that you see on the right-hand side of the screen, we will put in there, you got a score of 35, and on the last page, here's how the calculations were done, so that everything is above the board and there can be no arguing. So if you are into cranes, we try to mimic as much as possible what the real cranes are experiencing. We don't want to set the idea that you get on the crane, you load it up, it's already set, your LMI is set, and you're going to start moving things. No, that's you're forgetting 50% of their job, which is lift planning and load charts and setting up your crane, and that's what's more important. What better training would there be if you give the students best lift plan? You say, how many parts of line are you going to set for this for your rough terrain crane? And they say 4, and you say no. Go back and calculate again. You don't get on the simulator. That's wonderful training, and we hope to replicate that. So we give all the load charts. We give fully functional LMIs, so you have to set them. There's nothing automatic about them. You set the parts of line. If you want to use the jib, you can use the jib. It's completely up to you. The simulators are flexible that way, and therefore they take responsibility for the way that their cranes are set up before even operating. And what you see over here on the lower left-hand side is a hook block map. So we create a little icon. We'll drop a little tiny dot every 1 second. And what that represents over 3-hour scenario, 1-hour scenario, half-an-hour scenario is kind of your ability to control the hook block. Was it always plumb underneath the boom tip or not? And it's just kind of a one picture that encapsulates the productivity or the efficiency of the operator. So we're always trying to think of one way to kind of encapsulate behavior. We put the hook block maps on the cranes. Other things that we do is we have an optional instructor station, which offers a third eye view. So you'll see in the top right corner, that's the instructor station, which has the ability to fly around in stealth mode so that you can view the operations during runtime. You can also push a button and take control of somebody who can walk around the site. And you can view the way that the operators behave with somebody walking in front of them. If the bucket touches them, the simulation ends. If the bucket goes over top of them, the simulation ends. There's safety violations that you can observe at that point. Crew training is something that we're really pushing towards. So if you're into cranes, we'll do a tandem lift operation where you're both lifting up the pipe, as you see there on the lower right, and you position them in 2 different places, and then you do a tailing operations. One crane will be a tailer, and the other one will lift it up and place it into its final spot. So those are 2 simulators linked together to do that. Same thing with earthworks, an excavator and a dump truck, no problems working together. And what you have in the lower right is a signalman or a signaler. So they can be somebody who's inside the scene. You can see a little tiny person in the extreme lower left. That is this person, or this could be this person who's in the lower right. There's a webcam there. That webcam is projected onto the simulator, and they're giving the sign so that they're following the rules of the signalman. So you can have 4 people working in the same scene, inside the cabs, outside the cabs, everyone kind of working together like the big orchestra that they are. So crew training, as we're mentioning, so there's the 2 examples of crew training. R2C is working together to move a pipe around. Excavator and dump truck, you bump the dump truck, you're going to feel it. And the dump truck needs to go to a different part of the site to dump the load. excavator cleans up the site. If they're creating holes, the wheels will get stuck inside them. So it's all about moving a certain amount of material. And if you can do it in 3 loads or in 4 loads, working together, really backing up and using your horn for communication, all that stuff is inside the crew training. So our solutions, there's 2 I'd like to highlight here. One is called the Vortex Edge Plus, which is a very portable solution that clamps on a desktop. So what we see with this one is they're installed in big classrooms. So installing 15 of these in the classroom so that the instructor can lead training for a whole bunch of students and get them to have hands-on. You can pack it up into a case if you want, or you can take it to a job fair to kind of promote yourself. So what's important to know is that even though this is the most economical version of it, there's no motion platform. Everything's done on maybe a 42-inch screen in front of you and the laptop. It's the same software. So if you're interested in this one, or if you're interested into the top of the line, it's 100% the same software, the same smart training technology, the same crew training, the same operations. If you want an instructor station or a signalman, it's exactly the same. So there's no reduction of quality when you're working with the more economical solutions. So the one that was just released that we're working on, so this was just released at ConExpo, which is the top picture there, the Vortex Edge Max. So this one was designed with the idea of getting people onto the simulator. So it's compact, it'll roll out of the crate and set up very, very quickly. You got a 65-inch screen on the front that can rotate. So if you're doing cranes, it'll be vertical. If you're doing bulldozer operations, it'll be on the side because you want to see the material spilling off the blade. You choose. The equipment is there. You can remove the steering wheel if you want, but that's the only thing that you can remove. And again, same software. You can put them in tandem operations. And we kind of bundled it with all earthworks together or all cranes together. So this is the one that we really think we just want you to try simulation. This is the one that we position in price to get people to be convinced at the benefits of simulators. Full motion platform, no exposed wires. The computers are contained underneath the seat there, that little cover. Everything is very, very, very compact. And if you want to, you can put a rear screen on that, no problems. So that's the hardware solution. That's our philosophy. What I'll do now is I'll go quickly through the 2 different packs we have, the crane packs and then the earthworks pack. I just want to kind of give a flavor. I don't want to bore people with too much of the details. I like talking about simulation a lot. I like talking about these products a lot. But if you have questions, as Amir said, we can continue the discussion after. So I just want to wet your whistle a little bit about what we're doing, what's special about each one. And then if something interests you, let's continue that conversation after. So starting with the luffing tower crane. So on this one, what we really like is with anyone who has a tower crane pedigree, you know that it's all about load management. It's all about managing your pendulum. So the luffing tower crane, it's 16 ton. I believe it's I think it's 20 meters. I think that's what it is. So what this one that you can do is steel structures, controlling your pendulum, placing concrete panels. It's all inside there. Usually that one goes with a flat top tower crane, which has the same capacity. It's clearly a different crane, but has exactly the same scenario. So we offer those 2 together that you can perform the same tasks, the same exercise, the same evaluation criteria, but on 2 different types of cranes inside the same environment. So that you get the ability to work with both types of cranes in a kind of an apples to apples way. But this one was designed with Potin in France there. It's at their headquarters, and it was signed off by their professional operators. The things that are really neat inside here, you get rope slack that is calculated depending on the load. If you jerk your load up too much, the rope will slap the boom. Any tower crane operators will know that one. The mast will kind of corkscrew when you have a heavy load and you're starting to slew. So all that's inside there. Mobile crane. So this is by far the most popular one that we sell. Fully functional LMI. You can start either packed or unpacked, depending on if we want to do that training. At any point in time during the exercise, you can change the parts of line from 2 to 7. You can install the jib, but you have to go through the procedure. You know, telescope all the way in, bring the boom all the way down. You set the outriggers, and then you configure the LMI. If there's a mismatch, the crane will tip. It's as simple as that. And we give you all the load charts. We want people to fail. And it's the perfect time to fail so that you learn. I mean, failure is not a permanent thing. We want them to learn things that they can never learn on the real site. Learning nighttime operations, learning working in wind, learning when you configure the crane correctly, and learning when you hear the overload alarm. Like, what do you do at that point? If you want to, with all the cranes, you can make it so the next load sticks to the ground through the instructor station. When they attach and they try to lift it up with their slings and it doesn't move and they get the overload alarm, watch what they do. Do they put it back down and put their hand up and say something's wrong? Perfect. Do they struggle and strain? And no, then they need to learn more respect for the machine. So all that's inside all the crane operations. Crawler crane, 85 ton. So this one you can crawl around, do some very heavy lifts, nighttime operations are really nice on this one. So you have all the spotlights there. So it's a lattice boom crane. And it's based off of Manitowoc, if anyone is familiar with those ones. So again, with this one, the spreader bar on the back bounces around. With this one, we find that people would use it to fly around or jumping out of the cab just to teach the parts of the crane. That this is the spreader bar, this is where the winches are. Watch how the cable travels along the winch as you're operating. These are the counterweights, these are the tracks. So really getting them to understand the parts of the crane, that's often what's used on this one. So all cranes, all equipment, you can jump out of the cab at any time as long as the safety brake is on. The forklift, so this one was designed for the port, but we use it inside the construction. It's a smaller one. So maneuvering around small spaces. It's got the ability to change the spacing between the forks. So that one is basically really the heads up on that one for people who have never driven a forklift is the rear wheel steering. It isn't intuitive, and lining up the forks into the pallet is a challenge. So getting people to understand how that feels on a motion platform in the learning curve that they experience before they get on the real equipment. How do you deal with something that doesn't have a brake? How do you deal with just the accelerator controlling your movement? You get to kind of make the mistakes in the simulator first. So moving on to Earthworks. So again, this is all designed with John Deere, which isn't a huge brand around the UK, but they're slowly moving into it. But the point being is my relationship with John Deere was they get their version with their branding, but it was the CM Labs who designed it. So the equipment will feel like the John Deere tuned equipment, but I just kind of stretch it to give some respect away from theirs so that it doesn't look like there's any collision between the two brands. So let's take a look at these. Starting with the backhoe. So at any point in time, if you want to use the front or the backhoe, that's fine. This one is based off a backhoe that has backlash, for anyone who knows what that is. So that if you're violent with the backhoe, you have that kind of vibration that happens before the bucket settles down. So if you're a case operator, you don't know what that means, but if you're a CAT or John Deere, or I think JCB has backlash. Setting down the outriggers, you become stable. Setting down the outriggers with the bucket flipped over in the tripod position, even more stable. So that one really, you get the choice. You have a task to do and you set yourself up in the proper position, and then you're judged on keeping the material out of the safety corridors. You're judged on the cycle times. You're judged on how long it takes you to achieve it. So I like this equipment because it's a jack of all trades, but it doesn't do anything exceptionally well, but it does everything kind of well. The excavator, 21 ton. So that with this one, it's basically that's the workhorse. That's the one where you're understanding. You can have the two different control schemes, whether your ISO or SAE standards. You can switch those on the fly. Lots of practice on where to position your bucket, how to trace it along the arc, how to work with suspended loads, how to put some pipe down into a trench, how to make a trench, how to dig out a trench box. All that's inside here, plus some really fun, as with all the simulators, we always put in a trade show that it makes it fun, so that we find that the students, if you have a competition and you have a score at the end, they kind of challenge each other, and that's great because then they're just learning more muscle movements for whatever equipment they're working on. So for this one, it's about putting basketballs into a garbage can as fast as possible. The dozer is my favorite by far because it is ridiculously difficult. Any dozer operators out there will attest that you can get to the weeds very, very quickly. I held off doing this one for a very long time because with dozers, what you do is you have material on the front of the blade, and then the material slips under and you run over it with your tracks. So the tracks deform the soil. If you have too much material on your blade, then your tracks must slip. And if it doesn't slip, you're getting false confidence. So the dozer operators are playing on the decelerator pedal to play on the verge of track slipping or not slipping. That's when you're at your most productive. Playing with the RPM, trying to get that thing to move as much material in your slot dozing exercise or in your leveling exercise as possible. So we needed to wait 2 years for the technology to catch up with the ability to do what I just described. And we completed that last year. The wheel loader, working with a truss boom, it has a lot of the qualities as the backhoe. Working with forks, you can detach and put some forks on if you need. The wheels are squishy so that when you're going too fast and you go over a bump, you start to rock and roll. You're measured on duty cycles, so you're really doing production work there. If you're kind of going up and down a hill a lot of times and you're choosing the wrong gear, you have the wrong gear ratio, you're using more fuel. So you got the job done, but you could have done it better. And if you compare it to your instructor who used so many liters of fuel compared to your students, you can help them strive to doing the job, but doing it better or more efficiently. So all those efficiencies is really kind of what you can gain by working with the wheel loader. And the motor grader. This one is a beast. This one became so complicated because of the fully functional blade, saddle locking bar, if you know what that means, 6-wheel drive. The front wheels can tilt and they have a gimbal on them. Everything is simulated inside here. The equipment is so complex that my QA couldn't finish it. We had to bring in professional operators to finish exercises for the QA process because it's a very complicated piece of equipment that isn't intuitive. It requires a lot of work. So we've done 2 motor graders now that we got signed off with OEMs, fully functional. And this is usually the ones they show at trade shows like BOMA, if you go to those ones, or Conex, that just finished. This is the one that when you get grader operators on there and you get them recognizing that this thing behaves like the real equipment, there's a nice smile that comes about to that one because it's not something that they can show people very often. You end up working in isolation, but there's a real elegance to that machine that we try to get out on the simulator. So that one is a nightmare to demo because it's so complicated, but when you get a grader operator on there, he can really, or she can really make it sing. So with all that, a lot of technology, a lot of me talking about our product line. So what that all means, it can seem a little daunting that if you're looking to try to invest into simulators, it's not an expense. We can really help you with some media and some spreadsheets to help you understand how you can return on this investment. So what we do and what we like to do is to help people succeed. And if you have a training program, or if you don't have a training program, we can help you with the Sim Guide services to come to your site and look at your training program, understand how simulation can zipper into your work. So we did that with CITB. We've done that with many, many partners. It's a new training tool, and maybe it isn't obvious, but we can offer that kind of sit with you guys for a week to understand how simulation can get into here, how you can use it as a lab, how you can make it so that the students get more seat time and that you can go through your material quicker with simulations because the skills are validated. So we offer Sim Guide services to kind of facilitate all that. And of course, maintenance support, if you're ever having any problems, we're there. We have partners all over the world. If any piece breaks down, we get you a replacement very, very quickly. Generally, we don't have too many problems, but if you do, we have a maintenance and support program too. So, as I mentioned, if any of you guys are interested, what we can do is we have tons of pamphlets that we put together. We really enjoy talking about this. That might answer some more of your questions if you're interested. Amir will certainly be able to point you towards those ones and really help you answer the questions that you might have or soothe the anxiety that you might have towards adopting simulator technology. We've seen people take 6-week programs and get all the content down into 5 weeks when they adopt simulator solutions because of the accelerated learning. So that leaves them 1 week to elevate the entire class to a higher standard. We've seen people double their student enrollment because the instructor to student ratio has increased. Some of them are out on the real equipment with all that means and roping off. And the other half of the class, instead of smoking on the side, is in the simulator lab doing an exercise, and then they switch. So they're able to process more people quicker, and that helps return the investment quicker. So we put a lot of use cases inside those documents to help you understand how other people have done it. And of course, we're always willing to talk about it. So please let us know if you have any questions related to that. That covers, in a nutshell, what I wanted to talk about, but I appreciate everyone's attention that they had listening to me talk.
All right, thank you very much, Drew. Sorry to pressurize you and cramp everything in, I don't know, I think 40 minutes, 45 minutes maybe. So thanks for that, Drew. It was very informative.
And again, it might be a lot of information for everybody. And if questions come up later on, you have our email addresses. You can raise them at that point.
Okay, then. In that case, thank you very much, Drew, and everyone else that attended. Again, if there's any questions or if there's any follow-up inquiries, please let me know. Otherwise, thank you very much, Drew. Thanks everyone. I hope you have a lovely day and keep safe and stay in touch. Cheers.
Thanks, guys.